Today's 2 Minutes of Science is another in the series of Science is Everywhere. And when we're talking everywhere, we're talking even in these little tin toys. Now these tin toys are kind of interesting to look at and watch, and yeah, they're shaped like spaceships because I've said before I love spaceships and everything science and science fiction. The thing about watching these little spaceships move is it looks kind of random, especially if they start to fall off the table and I knock them back on, but in reality it's not random. The movements are controlled somewhat by a strange attractor. Yes, that's one of the strange attractors that's associated with chaos theory. You can see here how the winder itself comes down to meet the table and to make a turn depending upon how quickly the winder is moving, so that even though the reactions appear random, they're actually controlled to a certain extent by the movements of the wind mechanism itself. And that's the definition of the difference between, or one of them, between randomness and chaos. Chaos has controlling factors which limit the functions. The winder itself will generally keep these small wind-up toys within a certain specified area, although bigger than my table. Other places where you find chaos in use is weather systems. They appear random, or at least to us who are just waiting for our next picnic or a chance to see the ball game, but in fact there are factors involved, Coriolis forces and other things, which influence the way the weather works. That's why it's a chaotic pattern.